Alright, so in this section here, 5.3, we're going to take a look at how to take the derivative of an inverse function. And what I have listed below, this is our rule. If I want to take the derivative of f inverse, it's going to be 1 over f's derivative, but it's going to be evaluated at the value of the inverse, f inverse of x. And so there's two things I want to point out about this rule before we take a look at a few examples. One, I want you to note that the derivative, or the slopes, the derivatives of f and f inverse are reciprocals. And I want to point this out because, we've been dealing with derivatives for a while. A derivative is just dy dx. One of the things that you would have seen in pre-calculus is that the relationship between f and its inverse is that the x's and y's are just switched. The domain of one is the range of the other. Well, if you take a look at dy dx, and if I were to replace the y with an x and the x with a y, what would it turn into? It would turn into dx dy. Well, what's the relationship between those two fractions, or those two slopes? Well, they're literally just flipped, which is what we call a reciprocal in mathematics. And so that's the first thing I want you to observe up above, is that the derivative of one is 1 over the derivative of the other. They're reciprocals of each other. The second thing is that because the x's and y's are flipped, I want you to see, if I go back up here, this is x, and this piece right here is literally y. That function notation, or inverse function notation, really represents the y coordinate. So plugging x into 1 is how I'll say it. Plugging x into 1 is like plugging y into the other. Plugging y into the other. And these are the two ideas that we're going to be stressing on all of our examples. But for that second point there, I can't just plug the same number into both, because as I go from one function to the other, the role, or the x's and the y's, they switch. So if I'm going to plug x into one, I need to plug y into the other one so that things stay equivalent. Alright, so for this one here, I'm going to start off by taking the derivative of y by making it an implicit equation. So this example asks you to take the derivative of y, where y equals arc cosine of x. Well, right now, I don't know what the derivative rule is for arc cosine, but I do know what the derivative rule is for its inverse. The inverse of arc cosine is cosine. And so one thing I could do is I can cosine both sides of this implicit equation, keeping in mind that this y here still represents arc cosine. I still want y prime. I haven't switched the variables. I just cosigned both sides. And why this is useful for me is that on the left side, I still have just cosine of y. Although implicit, it's no longer solved for just y. Cosine of y is something that I do know the derivative rules for. And on the other side, whenever you have, I'll write it like this, we have a composition, an arc cosine being put into cosine. Since those are inverse functions, they cancel each other out, and I'm left with just x, which is something else I can differentiate with respect to x. So let's just do that. We now can take the derivative of both sides, since I know both of their rules. And on the left side, I get the derivative of cosine of y with respect to x. So that's going to be negative sine of y. There's the derivative normally. But then I have to multiply by y prime because the variables are different. And on the right-hand side, the derivative of x is just 1. And now I can go ahead and solve for y prime. Y prime is going to equal 1 over negative sine of y. And I just want to point out, again, I'll write it right here, our rule said that the derivative is going to be 1 over f prime of f inverse of x. And one of the other things I said was that you can think of this as y. And notice how we essentially have that right here. F prime. Well, f, in this case, is the inverse function of what I started with. So the inverse of arc cosine was cosine. Notice that this right here is the derivative of cosine, negative sine. And the second and last thing I want to point out, what do I have on the inside of it? I have y. I don't have x, I have y. But that's how we can find the derivative using our inverse functions. All right, so for this one, I'm going to do this two ways. I'm going to start off by using my rule that we've been talking about. So I want the derivative of f inverse evaluated at 8. So my rule says that the slopes will be reciprocals, so it'll be 1 over f prime, but I need to evaluate it at, not g, we haven't been using that notation, at f inverse of 8. All right, so there's two things we have to do. First of all, we have to figure out what is that value. So I'll do that over here in red. I like to ask myself, okay, f inverse of 8 is what? I don't have the equation for f inverse. I could find it if I wanted to, but a lot of these problems that you're going to see on the AP test, you're not going to know what the inverse function actually is. Because if we knew what the equation was, we would just take the derivative of that and not mess around with this rule. What I do know, though, is f. F is the cube root of x. And the relationship between f and f inverse is that the x's and y's are switched. So the x now is my 8, and what I'm looking for in f is the x value. And so I can think of this as, what do I need to plug into f in order for it to equal 8? Or when does the cube root of x, what do I need to put in for x so that this equals 8? And I can cube both sides, and I see that x is 8 cubed. That is what goes inside there. Because if f of 8 cubed is 8, then f inverse of 8 is 8 cubed. And so I'll go ahead and rewrite this. So we now have 1 over f prime of 8 cubed. And to end this problem, I need to just take the derivative of f and plug 8 cubed into it. And I'll do that over here in blue. F prime is going to be 1/3 x to the negative 2/3, just power rule. And I want to know what f prime is of 8 cubed. And if we were to plug this in, 1/3 times 8 cubed raised to the negative 2/3 power. When you're done simplifying, you're going to get 1 over, let's see, 1/3, and we're going to get 8 to the negative 2, which is 1 over 64. We could simplify this up, and I'm going to clear a little room right here. Our final answer would just be 3 times 64, whatever that number is. That will be the slope. All right, so for this one here, it says let f be x plus e to the x. I'm going to define g as the inverse function, and I also tell you that 0, 1 is a point on f, and defined g prime. Okay, so g is the inverse of f, so g prime of 1, that's the same as 1 over f prime, because their derivatives are going to be reciprocals of each other. But I don't want to plug in 1. I want to figure out and plug in what g of 1 is. All right, so let's do that. I'll do it in red. What's g of 1? Well, that's the same as asking, f of what gives me 1. And one thing that we need to note here is this given information right here. That is a point on f. And so I can see from there, when does f have a value of 1? That is when the x value is 0, right? F of 0 is 1. When x is 0, y is 1. And so the inverse, g, those are just flipped. G of 1 will equal 0. And so I'll rewrite that. I now have 1 over f prime. G of 1 is 0. And now I need to just take the derivative of f and plug 0 in. And I'll do that right here. F prime is going to be 1 plus e to the x. And if I plug in 0, f prime of 0 is 1 plus e to the 0. 1 plus 1 is 2. So my final answer will be 1/2, 1 over 2. All right, so for this one here, the table gives values of the differentiable functions f and g and the derivative of f at selected values of x. If g is the inverse function of f, what is the value of g prime at 3? All right, so in this case here, they're asking me to find g prime of 3. Okay, well, g is the inverse of f. And looking at this table, I know information about both f's value and f's slopes. So I want to use our rule for today and compare the relationship between g's derivative and f's derivative, which is that they will be reciprocals. So it'll be 1 over f prime, but I'm not going to plug in 3. I'm going to plug in g of 3. Okay, well, let's break it apart. What does g of 3 equal? Well, g of 3 is what I would love. I don't know. But that's the same as asking me f of what gives me 3. So where does f have a value of 3? That would be right here in this row. We can see that f has a value of 3 when x is 1. So when f has an x value of 1, it's going to equal 1. And so let's go ahead and write that down, 1 over f prime, and I want to evaluate it at 1. And then from our table, what's f prime of 1? Well, when x is 1, it has a slope of 4. So my final answer will be 1/4. All right, and the last one for this lesson. It says for all x, f composed with g and g composed with f are both equal to x. If f of 3 equals 2 and f prime of 3 equals 10, find g of 2 and g prime of 2. All right, so a couple things about this one. One, the fact that they're telling you that f composed with g and g composed with f equal x, they are indirectly telling you that f and g are inverse functions. This is the definition of an inverse, is when their compositions in both directions equal x. So f and g are inverses. The second part is this is really a part pre-calculus question and a part calculus question. Find g of 2. Well, that's a pre-calculus question because what's the relationship between the values of f and its inverse? Well, the x's and y's are switched. So up above, they tell me that f of 3 equals 2. So therefore, g of 2 has to equal 3 because the x's and y's are just switched. So g of 2 will just be 3. The second part, what's g prime of 2? That is the calculus question. What's the relationship between their slopes? Well, we know that the slopes are going to be reciprocals of each other. That's one property. And I'm not going to evaluate it at 2. I'm going to evaluate it at g of 2. Well, we just found, just to the left there, I have it circled here in red, g of 2 equals 3. So what's f prime at 3? That's given to us up above as 10. So g prime of 2 then will be 1/10. All right, so overall, this formula right here is going to be key to any derivative you have to deal with inverse functions. Remember that the relationship between a slope of f and its inverse, they are reciprocals, so it's going to be 1 over f prime, but you have to evaluate it at the correct value. So you need to figure out what the y value is. So if I want to plug in 2, like we did here, we have to then figure out what g of 2 is to plug it in. I hope you found this video useful.